Welcome to all of you. In this lecture, let us realize full adder as well as full subtractor using multisim. Let us first start with the full adder. So this is the truth table for the full adder. So it is going to have three inputs A, B as well as carry in. The outputs are sum as well as the carry out. Now this is the binary addition we are going to consider. So all three inputs are 0, output is also 0. Then input 0, 0, 1, output is 1 and 0. Input is 0, 1, 0, output is 1, 0. So like that we'll proceed till 1, 1, 1 is the input. Output is going to be sum is 1 as well as the carry is 1. Now mapping these values, output values sum as well as the carry onto the K-map, we are going to end up with the corresponding expression. So this is for sum. We are going to get sum is equal to so and so expression. By reducing that, we are going to get carry in XOR with the combination of A XOR B. Similarly, by solving for carry out, we are going to get carry out is equal to AB plus BCI plus ACI. The grouping is being shown over here. Right now, representing this by making use of the basic gates, we are going to get this realization. So this is the sum part what has been realized, and bottom one is going to be the carry realization. So since sum consists of two XOR operations, so here itself we can observe two XOR gates. Carry consists of both AND operation as well as the OR operation. Therefore, two AND gates plus one OR gate is being used. Now let us first realize the full adder on multisim. Let us start with the multisim. So first let us start with selecting the component. So here is what you can observe, the expression for sum as well as the carry out. So based on this, let us identify the required components and let us rig up the circuits. So I am just trying to start with the sum. So sum, it is XOR operation, two XOR operations are there. So I do require two XOR gates. So let us first select the XOR gates. So XOR, so number I'll directly type, it is 7486. So I'll be selecting 7486. So the first one I have selected, I'll be placing at the beginning. Right, I do need one more. Select one more here itself, and then I keep it at certain distance. So two are enough. Right, so then what we need next to that one, so for realizing carry I require an OR gate, AND gate and XOR gate, which we have already taken. So the same part we have taken, therefore we need not to have one more XOR gate. AND gate as well as OR gate we require. So let us take the AND gate first. So it is 7408. Two input AND gate. So I'll be selecting the first one. So first one I'm going to place it over here. So let us take it with the sufficient distance so that I can place the required components somewhere in the middle. Right, I do need one more AND gate. So at the middle part I'll be placing this. So that's all. So I do require one OR gate. Two input OR gate I will be selecting. So this is for carry out at the final. So we can rearrange the components position later also. So I'll be just placing over here. Right, one OR gate is sufficient. Then we do require input source. So for that, so I need to have sources, digital interactive source, and say okay, two inputs A B as well as C. Total 3 inputs we require. Right? So then in order to verify the output we require probes. So probe red color I will be preferring. So say OK, and I will be placing over here. Right? So we need one more. Let us place that over here. Right? So that is enough. So let us close this. Right? So now we need to make the connection. For that let us make required rearrangement. So place it over here and this one over here and this one over here. Right? So for easiness let us designate this as A and then input B, double click, input C in. I will be writing for this. Let's make it small letter. Right. So better understanding. So now let us start connecting. So let us start with the first part. So A and B to the XOR gate. So this part I am realizing A XORed with B. That's what I am realizing first. So A XOR. So then one more input B right. So A XOR B completed. Then the output of this has to be connected to one more XOR gate, that will become C input XORed with A XOR B. So A XOR B is one input for the second XOR gate and CI, that is C in, is one more input to this one. So output of this has to be connected over here. Then one more input I need to provide. So let me take up to this point, then take a deviation. Right? So some part is completed. Now let us go with the carry representation. So carry is first AB, let us realize. So AB input over here. So this is for A, one more input for B. Right? So second part. So there is A XOR B. So this is what A XOR B. This has to be ANDed with the C input. So let us first take A XOR B. Then for that I will be adding C input. Right? And this has to be ORed with using an OR gate. Right? So let us perform the OR operation between these two outputs of the AND gate. Now connecting this AND gate output to this OR gate and this one over here, no problem. Okay. Now output, fine, output is also connected. Now we can verify the truth table of this one. Right? So let us first select the truth table for verification. So let me copy the truth table. So the truth table is here. I'm just copying that. So I'll be pasting that over here. So it's quite a bigger one. Let us place it over here on this itself. Okay. Here also we can make a verification. Let us go one by one. So let us simulate it, run it first. So run the design. Now all inputs are 0. these outputs are also 0. And remember, you can designate this output as sum as well as the carry, so or you can leave it as it is. So let us just make that also. So let us consider this as carry out, carry out, and the first one as the sum, first one as the sum, right? So now I can verify that table very easily. So run this. So input 0 0 0, the first one. So the output is 0 and 0. Input 0 0 1, output is 1 and 0. Then 0 1 0, output is 1 0. Yes. Then further, let us take further, 0 1 1, sum is 0, carry is 1. So then similarly, the other values I will be verifying. You can just go through this truth table. I will be verifying the other values. So then 1 0 0, sum is 1, carry is 0. 0 1 0 1, so sum is 0, carry is 1. And then 1 1 0, sum is 0, carry is 1. And all 1, sum is 1 as well as carry is also 1. So the last value, let us make a check in the truth table. Yes, all 1, sum is 1 and carry is also 1. Right? So similarly, we can also proceed with the full subtractor. Let us continue with the full subtractor. So this was the truth table for the full subtractor. So 3 inputs, A, B as well as C in, and then the outputs are going to be the difference as well as the borrow. By solving for difference and the borrow in the K-map, we are going to end up with these expressions. The difference is going to be this expression as well as the borrow is going to be this expression. Right? By realizing these two expressions, by making use of the basic get, we get this realization. Right? So now let us rig up this realization on the multisim, and let us verify with respect to the correctness of the truth table. Let us continue with the existing full adder so that we can make out this as a full subtractor. So now here is going to be the circuit representation for the full subtractor. So in comparison, we can just say that the two NOT gates has been added to the full subtractor with respect to the borrow expression. Now let us make out that those two NOT gates. So this one, I need to add one NOT gate over here, and here I need to add one NOT gate. Right, so for the easiness, let me just drag it a little bit down so that I can easily place a NOT gate over there. Right, so I can also make it a little bit back. Fine. So now let me select the NOT gate. So here will be there with the digital ICs 7404. I can make a selection. Right, so place it. So this is over here. I need one more. I'll be placing over here. Fine. So 2 are enough. So close this. I need to rotate this. So Control R I will be using. So now I will place this over here. Right. So one and one more. I will be rotating, and I will be placing this over here. Right. So now make the connection for this. So let us connect it over here, and then okay, then make a connection to A so that it will become A dash. Then it has to be connected the output of XOR gate. Right, now the connection has been satisfied. Now we need to make a verification with respect to the truth table for that. So let us verify the truth table. Let me have the truth table. Okay, here it is. So let us make the verification of that. So let us set the input to all zeros, right? So now here it is not the sum, it is the difference, right? And this one is not the carry out, this is going to be the borrow output, right? So many times it considered as borrow out over here at the output, and here it will be considered as borrow in, but anyhow I'll be keeping this as C in only. So now let us start the verification now. So I'll be running this, so run this. So now it is running. So we need to verify the truth table. So input 0 0 0, output is 0 0. Let us make 0 0 1. So output is 1 and 1. So both are glowing, correct? Then make 0 1 0. Now both are glowing, right? So then 0 1 1. So 0 1 1, output is 0 and 1. Yes, 0 and 1 here. Then make 1 0 0. So here it is 1 and 0, right? 1 and 0, right? Then 0 1 0 1, let us make. So output is 0 0. Then make 1 1. Yes, output is again 0, right? All ones. Then more difference as well as the borrow are going to be 1 and 1, as we can see in the truth table, right? So this is for the verification of the full subtractor by using the basic gates. Thanks for joining.